areas and the thrust areas. There are basically some thrust areas like AI, IoT, blockchain, robotics, data science, cybersecurity, 3D printing and design, augmented reality and virtual reality, and including other areas like emerging areas like engineering, management, arts and crafts, design, and media life skill management. So I'm extremely happy and thankful to AICT for sanctioning this particular FDP program. Not only this, they have sanctioned 4 programs. This is the first program we are conducting virtually this time. Another 3 programs will be conducted. I thank especially the director Ravindra Kumar Saniji for allowing NIT Mizoram to conduct this program. So far this program is concerned, the electric vehicle is the need of the hour, as Professor Chatterjee has already mentioned. And I, being the part from the mechanical engineering, is extremely happy to see that, yes, this is also coming up and it will be extremely helpful for the teachers also for research. And in the new education policy also, that we have to see that Atmanirbhar Bharat, that how we can develop all this indigenously. So I'm sure that with the experts delivering issues, especially with that your issues like recharging battery takes time. These are some issues of electric vehicle. Recharging is an this point, and difficult to get a charging station is another issue, and there are very less number of models. These are some of the issues what I can find. But again, there are some companies like Mahindra, Tata, Hyundai, they are coming up. And by 2030, what I can expect, and Tata also said that yes, there may be around 43% electric vehicles will take the market share. And obviously that will with the COVID situation, this is the need of the hour, because you know that pollution is a big issue. So with this backdrop, I welcome all the experts, and I congratulate Mr. Anand Bhattacharya, the coordinator of the program, a grand success for this program. And I also request all the participants that you got a chance to listen the experts all over the country and take the full advantage of this. Once again, I wish the program a grand success. Thank you very much.
Thank you, sir, for your words. I welcome all the participants all over India. We have got representations right from the extreme south to the extreme west to the north. And sincerely, it's possible. We hope someday that we meet up in the NIT Mizoram campus in future. But till then, we have to meet up this virtually. Now, I would like to introduce Professor Bhim Singh into the audience. Professor Bhim Singh has received his BE Electrical from University of Roorkee, India, and MTech and PhD from IIT Delhi. In 1983, he joined the Department of Electrical Engineering, University of Roorkee, which is now an IIT, as lecturer and promoted as reader in 1988. He joined IIT Delhi in 1990 and moved to the post of professor in 1997. He has been ABB Chair Professor from September 2007 to 2012. He has also been CEA Chair Professor from October 2012 to September 2017. He has been head of the Department of Electrical Engineering at IIT Delhi from July 2014 to August 2016. He has been the Dean Academics at IIT Delhi from August 2016 to August 2019. He is J.C. Bose Fellow of DSC Government of India since 2015 December. Professor Singh is the chairman of BOG MNIT Bhopal since 3rd July 2018 for 3 years and non-official independent director of NTPC Limited since 17 July 2018 for 3 years. He is CEA Chair Professor since January 2006. Professor Singh is also the member of Governing Council of CPRI India. He has guided more than 90 PhD dissertations, 168 ME MTech projects. He has filed 60 patents and got a huge list of publications, along with a textbook co-authored Power Quality Problems and Mitigation Techniques published by John Wiley and Sons. His research areas include solar PV grid interface systems, microgrids, power quality monitoring and mitigation, solar PV water pumping, improved power quality, AC/DC converters, power electronic, electrical machines, drive, tracks, and electric vehicles. He is the fellow of FNAE, FNA, FASC, FTWAS, FIEEE, FIET, FIE, FIETE, IST, SSI, and NQR. He has received the Khosla Research Prize of University of Roorkee in the year 1991. He is recipient of J.C. Bose and Bimal K. Bose Awards from IETE for his contribution in the field of power electronics. He is a recipient of Maharashtra State National Award for Indian Society for Technical Education in recognition of his outstanding work in the area of power quality. He has received PES Delhi Chapter Outstanding Engineer Award in the year 2006. He has received Faculty Lifetime Research Award 2018 for overall research contribution at IIT Delhi. He is recipient of IEEE IAS Outstanding Educator or Mentor Award in 2020. Professor Singh is also the recipient of IANE Outstanding Teacher Award 2020 and Eminent Engineer Award 2020 from Institute of Engineers. He has been the General Chair of several conferences including PEDS 2006, Indicon 2015, and the General Co-Chair of National Power Electronics Conference held in Pune. So I would now request Professor Bhim Singh to take over the session.
Well, good morning to all of you. Thanks, Professor Anang Bhattacharya, Professor Ajay Gupta, Director of the NIT, and Professor Saibal Chatterjee, Dean Academic, and of course Ananga and other faculty members, Dean, and participant. It's my great pleasure to be with you. All of you. I've been asked by Ananga to deliver one lecture, so I thought it is right, good time. To waste time on the travel. So it is good time that I can talk to you. Otherwise, you have to take couple of hours of and go and come back. So, but that is another side that you can connect probably all the people from not from India, but you can request from abroad also in the area. So this will give you a good opportunity to interact with the participant, large number of participants. The another important is that we have to engage young blood in such a situation when a lot of stress. I got yesterday even from mail from our director, Professor Ram Gopal Rao, that there is a lot of stress on the student. So especially asked by faculty colleague to take care properly. There is this epidemic has created a lot of problems. So this is the right time to engage. At least if we can't do anything through such kind of at least enhancing their knowledge or concept, like either for research or for probably for the new technology, at least in the area in which probably they want to plan their career, or they want to do research, or they want to go little higher study or so. So I would like to certainly welcome you all the participants, and I think you will get a good opportunity to interact yourself. Maybe what Professor Anand Bhattacharya already talked. Maybe the time will come certainly. Probably people will be able to come to the campus of NIT and meet all among interact. Of course. Otherwise, such a FDP or conference is very purpose that people interact. But of course, physically you can interact, but it will be right time that you can discuss with the expert also, or yourself a common platform about the course. With this, of course, I have to probably deliver a talk. So maybe after inauguration, I'll come back to you for delivering a first talk on electric vehicle, just overview and probably some of the concept like how it is coming up. So with this, I would like to again thanks to the organizer to be with you. Thank you very much.
Thank you, sir. Thank you. On
Okay.
behalf of NIT Mizoram, once again, I welcome you and namaskar from my side, sir.
Namaskar, Doctor. Thank you.
We are very much grateful to you for accepting our invitation. Thank you, sir.
Maybe we will meet sometime. Thank you.
Yes.
So now I think we can start our session. So I will request Professor Bhim Singh to directly start the session, since we are a bit late today, and that will be better, I think, if you can directly move on to the session. So Professor Singh, you can move on and start to the session directly. Sir, can you hear us? Hello. Am I audible?
Yeah.
Yes, sir. I think you can directly start the session so that we can move on to the
Okay.
your session and talk directly.
Okay. So shall I? Can you see the slide now? Hello? Can you see the slide?
Not yet, sir.
Okay. I have to call like trying to share like I think. Hello? Okay, एक minute
Hello.
like
Yeah, it's now coming. I think it should now come. Yeah, it's
it's
coming.
coming?
Your screen.
Okay.
Yeah, your screen is shared. Yeah.
Yeah, it is okay now. Slides is
Yeah,
visible?
your screen is shared. Yeah. Fine.
Okay. Okay, thank you, like okay. So I can start with Ananga?
Yes, sir. Go ahead.
Okay. Think uh, I think I can probably reduce it. So maybe I don't know question people like to put in between, or maybe we can take on the way. Anyhow, let's say start like electric vehicle overview and its scenario in India. I mean, like coming to electric well, it is started. So little bit history if I give you. I mean, like here, well, it is started as old as like 1828, and I will probably will pass on the slide to Pasananga, and he can pass on to you about this history how it has gone. But I can tell you the technology got developed. I mean, probably around early. I mean, like a end of typically of 19th century. I mean, these are the development how it has gone to different parts. And in 90 around 90s, typically around 2000. I mean, 96 or something. The GM launched in California, but they have to come back, and that really showed that there is a right time for technology launch. Um, I mean, like in a way. So, well, that time was the problem of storage, so they couldn't go to the technology too much in probably 96 or 95, and they have to withdraw. But the technology which it developed, it does not go waste. That time, the major constraint was or limitations was the energy storage, like a battery capacity that you cannot take the back a longer one. So what is it is changed into, I mean, after that around probably the concept came in 97 and start commercially around year 2000, typically about the hybrid, I mean, like which have seen probably almost more than 1 decade. I mean, like, so hybrid in the sense that you have an electric motor as well as you have your typically the internal combustion engine also, but the internal combustion engine capacity reduced to approximately half. Why it is? Because half the torque for starting you can get from the electric motor and half may come from engine. So you understand in electrical engineering, I mean the major, let's say if the motor, I mean even induction motor you start directly from line, it draws 5 to 7 times the current, like and probably 3 times the rated power. I mean at starting and giving a very low torque, provided you are not controlling it by variable frequency drive, which we'll talk about a little bit. So the same thing in a, your internal combustion engine. I mean you need a very large brake horsepower and gear arrangement to match the characteristic of your vehicle propulsion system. I mean, from this, your typically with the automobile engine. So that was requiring a huge rating. But when the large rating, either your engine or motor, you run at partial load, the efficiency goes very poor. That was the one of the reasons. So here, I mean, initially the motor as well as the engine is giving the torque. So rating, that's the reason engine rating is reduced. And while in running, that engine rating was enough, but the major limitations of the range was taken out because whatever the battery capacity you have, you can drive with the electric motor. Maybe in local driving every day, you can drive with the electric motor. But in long run, if you want to go on highway for long travel, then you can certainly go to the internal combustion engine also. So that limit was, and but majority travel like a local travel, which normally we do day to day, maybe like 100 kilometers something, that was certainly by electric motor. So this around a decade, I mean, hybrid vehicle have been very popular in, especially in North America as well as Singapore or many countries like I mean also. But now time has come. At the moment, like typically most of the leading manufacturer, as you see some name here also, they launch the electric vehicle now. And of course, Tesla have been the one which have been probably quite popular in the world. I mean, a quite good luxury car, and they are able to demonstrate. I mean, now range is not the limit because on single charge you can certainly have more than 500 kilometers. More than that, you can't drive it in a single day. I mean, so that range, NXT has already gone. Like, I mean, at the moment. And there have been a many benefit, of course, that limitation gone, but the benefit you can take. And what are the benefit of electric vehicle? Can you think about like the one of the major benefit? Of course, this is the typical how much the one is the region that we were using around 49.87%. I mean, on the road, this oil consumption, what we have total in India. And this, if you look into the red, is the demand of oil for this vehicle propulsion, and the your blue is the typically available oil with the time. So you'll find after some time there is a big gap. So it means either you don't run the vehicle, I mean maybe with the your internal combustion engines, I mean like otherwise you'll not, or it will go very high, even then you will not be able to run. So directly or indirectly vehicle have to be reduced if you totally trust on the on world oil production. So that is another reason, like you have to find the way. And another is major reason is the pollution. I mean, pollution, I mean, carbon dioxide pollution is quite high with the internal combustion engine. Another is your climate change, like a temperature rise, as you see with the typically, I mean, if you look into in the last typically 40 years, the temperature have gone more around 1 degree higher. I mean, like, so as a global ocean, land ocean temperature index. So that's also another worry. And have been a various emissions from internal combustion engine, like carbon dioxide, organic compounds, then nitrogen oxide, particulate matters, carbon monoxide, and it harms the environment. So a lot of pollution have been there. Typically, I mean, you can think about when you apply the brake, like a city like in Delhi, where you can't maintain the speed high, so you apply the very frequently the brake. So when you apply mechanical brake, entire energy goes into the dust and particle, which remain floated at least for 2 3 months, like starting from middle of October to go to middle of March. I mean, because you don't have I mean, typically either no rain and no winds, so it remains suspended into the air, and that's the reason the pollution index goes very high. I mean, not so. So that is very harmful to the health. And another commitment have been probably this on the climate change 2017 panel, which have been with the through 2015 with the Paris Agreement. I mean that you should reduce the like carbon emission and the pollution, and you should maintain the, I mean, worry about the climate change also. So another major reason, so that is one side that okay pollution. Another is that, I mean, if you look into the electric vehicle, probably you will be able to run with the renewable, and renewable cost is going down. At the moment, you can think about if you produce the electricity from diesel or petrol, the cost of electricity will be around 20 rupee per unit, like kilowatt hour. But if you produce by probably maybe the grid electric power, I don't know what is your place, but in Delhi we are getting in IIT around 10 rupee 25 paisa per unit. But solar at the moment is 2 rupee 34 paisa in India. But of course, in some of the Middle East like UAE and all that, the cost of solar generation have been only 1 rupee per unit. So that time is not very far that it will reduce really. I mean, it will come to the even order of 1 rupee per unit or so. So you can differentiate the difference in 1 rupee, 10, 20, 10 rupee, and then 20 rupee. So if the cost of electricity go down, you cannot run the your certainly automobile car with the help of typically from the your electricity, but you can run certainly electric car, and this electricity can be certainly produced by in very cheap manner from these renewable energy sources, either solar or wind, which is coming up like PV. Even India have gone to 175 gigawatt. Out of that, they have planned it for typically 100 gigawatt solar, which is available in almost all the places for reasonable longer period in the year. Like, and federal government have decided to go big way. And you can understand because of this, even in Delhi, the government of India, I mean, I have procured some car especially for the central government offices, and their estimate came into newspaper that the cost of typically a per kilometer distance at the moment is around 79 paisa per kilometer. I mean, whatever the battery, I mean, charge battery electricity you consume in that. But if it is like at the moment, you can think about electricity 10 rupee 25 paisa. But if this electricity comes, let us say, order of only 2 3 rupee, I mean, suddenly reduction to one fourth, probably that 80 paisa will become around 20 paisa. So you'll be able to run your electric car, I mean, only in 20 paisa per kilometer, 25 20, I mean, a quarter rupee per kilometer without much problem. So the operating cost, running cost will be very low. I mean, like you can think about at the moment we might be running your petrol car 5 rupee per kilometer, but if it comes only 25 paisa per kilometer, you'll be able to appreciate that this operating cost certainly will make a major impact. Why we should go for electric vehicle? So running cost will go down. I mean, it's already down, but it will further will go down. And you can understand. So, I mean, if we look into all the advantage here, the one is the energy efficiency, which I told you that you require very low fuel. The fuel, I mean, like a typically of, which is maybe typically at the moment, maybe 1/5 or so, because like 80 paisa compared to 5 rupee of petrol for a kilometer. So it's already, I mean, like a typically 1/5 or 1/6 like also. And day by day, it will be electricity, I mean, by renewable will be reducing day by day. And of course, the oil prices, I mean, will be going up. So this gap may increase probably 10 times or 15 times, maybe in next couple of years coming up. So we have to think about also. Another is, of course, we take a oil import, and this energy, which I'm talking about, solar wind, we normally produce locally, like, I mean, including your own rooftop also. And well, another important aspect, which is a major benefit, I mean, the pollution, okay, and then the avoiding greenhouse gas emissions, the noise reduction, and of course, it will cause a new change of industrial revolution to provide the employment to the people like also. So here the no fuel, I mean no emission. That is one important in case of your fully electric vehicle, and you will reduce the carbon footprint decimally. Another is that it will be cheaper to run, as I already mentioned, for per kilometer compared to petrol or so, and because we can use the renewable energy for charging and reduce the cost of charging like anything. And moreover, I mean, if you talk about even from the same electricity generated from even conventional sources, is still, I mean, because the system chain in case of electric, I mean, your vehicle is much efficient, so you will be able to get around 23% compared to your automobile, around 13% or so. So another now, which was the limitations, was Tesla already proven 300 miles around 500 kilometer single charge, and this Volgan have already gone to 400 miles per charge, which might be 600, which you can't run more than that distance in a day or so. And another, of course, which have been a benefit about your good news for the health, it does not give the pollution. I mean, it does not really affect too much your health. So another is the vibration. I mean, vibration also reduce here like drastically down. So it is very quiet or silent. I mean, running with the electric vehicle compared to automobile. An electric car runs on electricity powered engine, hence no need of lubricate the engine. And another very important is the moving parts, which are hundreds in conventional automobile car, which reduces to only around with electric motor less than 20. So number of components, I mean moving components also reduced to 1/5 or 1/6 in case of EV electric vehicle. This is another benefit like. So that caused the reliability to increase, okay? And you have a long-term maintenance cost also lower for electric vehicle like also. The one of the major advantage which I have not mentioned so far is the kind of a regeneration. I mean, we were doing something for Delhi Metro very recently. We found the Delhi Metro, the last phase Delhi Metro. I mean, the company or industry which took this tender is on the base of, typically they claim that they have a 40% regeneration. I mean, even in Delhi Metro. And you can understand the metro route is all well defined, all stations are well defined. So it means you are having so much, typically, let's say you are applying so much brake or stations are so closer that 40% regeneration is claimed in even your metro. But if you talk about your electric car running like a density like Delhi, I mean, the regeneration may touch even 50% like also, because here you are not going to stop only the vehicle on typically on your, you can call it traffic light, but you have to even apply the brake very frequently, and because of heavy traffic in between also. So since you will be applying, I mean, reasonably number of in a city like Delhi, very frequently, so regeneration will be substantial, and it is expected the regeneration will be order around 45 to 50%. So another benefit is that the 50% energy you are recovering back into the battery by regeneration. Otherwise, this entire energy might be going to pollution, because you might have applied the mechanical brake, which goes to dust particle, very fine dust particle on the brake, and will really affect the health. But here you are taking this energy back. So one is that the electric motor is efficient, I mean, which you already talk about. Another is you are recovering the energy, reasonable energy, 40 to 50% energy back. So that makes certainly the major difference why your running costs get reduced, like drastically down here. In electric vehicle. So that is one side. The some of the benefit I can mention it why we should go electric vehicle. There are other benefit related to the electric power grid, because people talk about when you will be charging this electric vehicle, it will cause the problem in electric grid. But now technology coming up that not really create the problem to the grid, but you can provide the ancillary services to the grid with the help of this modern. We expect the chargers like ancillary services in a sense like a reactive power support, because you for a bidirectional power flow chargers, like you should be able to sale off part of your battery energy when the electricity cost is high. Of course, this concept is not in India because we have a more tariff related to the because of political system. They are related to only flat rate, but it's not so in case of developed country. The tariff rate depends on time when you have excess energy, because and this situation will be more prevalent when you will have a renewable energy. So sometimes you will find you have excess energy on the grid, and sometimes there will be a shortage. When you have access, the rate of electricity will be cheaper. You can charge the battery, but when the cost of electricity goes up, you can sell off part of your energy of the battery, because if you are running like in a city like Delhi, certainly you will be able to, sell off probably, and cost varies even at the moment. I can tell you interestingly. I was interacting with both the company which are supplying the private company, distribution company in Delhi, and they say, sir, we are buying around 9 rupee 50 paisa in summer and buying the electricity at 2 rupee 50 paisa in the winter night. So this is the difference already for distribution company, but they are not supposed to reflect this all these varying tariffs to the public. Like so, but the what I mean actual fact is there of the cost of electricity changing with the time. So under such situation, your energy storage which are in the vehicle battery will be able to provide the support for the grid to make the grid smarter and to make a grid stable also. Only you have to provide the facility. Okay, you charge at the lean period when electricity is, already more because of renewable integration, because that is also intermittent. To avoid the intermittency of it, certainly the cost of electricity have to change. So these are the storage of the battery of the vehicle, which really provide you all this flattening and your smart grid concept. I mean, with that, and this storage is very interesting, because if you could have kept it a battery energy storage at a one location, very large battery energy storage, like you has developed 10 megawatt for 4 hour peaking capacity. Chinese also developed 9 megawatt for 4 hour peaking capacity, but require a huge investment as well as huge space as well as the replacement of battery. So that is not required in typically if you are utilizing this battery vehicle. Another is these are distributed in entire distribution system. You might be parking your car at different locations. So it's not at concentrated at one place. So you will be drawing the power for charging also well distributed in distribution system. So you are not causing the problem, power quality problem even for distribution system also. But you will be able to provide even if you are not putting active power and your charger is connected to the grid, and which is a charger of typically we consider it the bidirectional charger, you will be able to provide the grid reactive power support to the grid, as well as you can track the renewable energy sources also, as I told the cost, and you can provide other, services also, because your voltage source converter is as a front end converter for the charger, so you can provide the services of load balancing and other power quality improvement also, even with your these chargers. Like so, that makes really a big difference. Typically, the facility even from the charger, like, and of course, other benefit about your center gravity and all that, the less risk. Like you can understand the your pollution level in battery electric vehicle, as you can see here, compared to your internal combustion vehicle. Like it's a big difference between the two also, as far as your typically. And this is like how the your world electric car stock is changing from 2010 to typically going to 2019 or so. Like just see the graph how exponentially it is going throughout the world. Like also, and certainly the charger, typically the charger also, because that is also requirement for a vehicle also. And you will surprise that in India how many vehicle we have. I was talking about what is the right time for the launching of technology. We have around like a 3 crore e-rickshaw on Indian road. So you can think about the many countries may not have even a population equivalent to that. What we already have a your electric vehicle in India, light electric vehicle in India, and it will be coming up. Those are typically you can call it up to some extent. Has given a if 3 crore electric vehicle are there, they have given employment for 3 crore people, and to whom those who are unskilled, people like, government even can't provide so easily the employment for 3 crore people or so up to that extent. Like, but this is a technology-driven concept that this electric vehicle will be providing a large employment to the people, in the community like India or so. So there are, of course, various typically announcement by electric manufacturer. This OEM, that BMW, Daimler. So, initially when the federal government have decided to go for electric vehicle, that is, they were deciding by 2030 we should have an all electric vehicle, and almost the Indian this automobile, manufacturer came almost to revolt. Like how they can do, and there have been a big lobby kind of thing. But they also interacted with all the manufacturer of these automobile vehicles in probably in the international world, and they found most of the all these manufacturers, those who manufacturing the automobile and internal combustion based your vehicles, all they started manufacturing this electric vehicle also. So finally, they have to also agree that we cannot deny that in India also the electric vehicle will not come, because we have a more problems. We have to import the oil, and we have a higher pollution level compared to those developed countries. So of course, the requirement is huge. If you have a 130 crore population, suddenly you require 130 crore more than that, the number of vehicles like also. So that, of course, majority of company GM22 models are already supposed to be by 2022, and more than 1 million electric sales around by 2025. They already declare what will be their plan for the vehicle launch in the next future few years up to 2025 or 2022 also. Including the Maruti, they are expecting in 2021 up to 1.5. Up to typically 2030, like, also. So they are also bringing a lot of models, even Indian manufacturer Mahindra also. So you'll find that's the reason I asked my student to make the slide properly with the latest announcement what the electric vehicle manufacturer are already put it to also. So, well, these are different manufacturers. Then we come to, of course, classification. Initially it has been internal combustion based, and then later on hybrid, then plug-in hybrid, then range extended electric vehicle, battery electric vehicle, and fuel cell electric vehicle. So battery electric vehicle we are talking about, or plug-in electric vehicle. These are the typical, the vehicle are coming up also. And how the range and all that. And this is a concept like how if it is a conventional, then hybrid, and how battery vehicle. So you'll find that you have a motor, and same motor work as a generator when you have regenerative braking also in your battery operated vehicle also. And of course the hybrid, different configuration of hybrid which are already well reported, because a lot of hybrid is already manufactured and used in even very nearby typical country like Singapore also, like, also. And of course how it has gone to micro and then remaining development, a competitive like battery electric vehicle. What is the competitive issue? How day by day not only you are going to replace, but you are supposed to provide the better services, then only probably people will be able to probably adopt the electric vehicle also. So all the relative features and your merits of electric vehicle like also. Then the major, reason have been your energy storage, like a battery system. So there have been a plenty of battery system, like as I mentioned few minutes before, typically about the your 3 crore e-rickshaw, they are using lead acid battery, which survive 3 to 4 years. But there have been a lot of innovation coming up, like energy storage, not only the batteries, but coming up like ultra capacitor, as well as typically coming up like your ultra wheels, as well as fuel cell throughout the world, and how it is the development have been gone with the fuel cells also, like typically also in the energy storage for these all, and different kind of, not only this, people are trying a lot of concept like they can be have a fuel cell and other things also, and how this is life chain of the battery is going to be revolutionized after typically including the recycling and use of this vehicle also. And typically energy storage, what you should think about how efficient, what are the requirement, and how day by, and you'll surprise that day by day, and you'll find a major improvement coming up in the vehicle, typically especially energy, let's say storage or battery technology like also. And that's expected that we will have a good battery technology in very few years like also. So there are different kind of battery. There are slow battery like Girl battery, their life is very high, okay, and they might be serving the purpose not in the vehicle, but might be for the charging in station or charging infrastructure, which I will talk about after 3 minutes or so. Like, so there have been otherwise the lithium-ion battery. Most of you might be aware that at the moment they are costly, but certainly cost is going down day by day because they have to go for mass production. There's no matter which country they are manufactured or so. So there are plenty of kind of battery if you look into, I mean, which are going to already available in market and with a lot of energy, increased energy density. You can think about as high as like maybe 260, and with the 1C or even including the like a typically with the different charging hours or so, and how the battery concept is there with the lithium ion. In lithium ion also you'll find around 20 to 30 type of the battery concept are coming about to compromise between the cost and the quality and other things. And another is a nickel iron. So because of this electric vehicle, lot of research and lot of concept have come, and lot of development have come in battery technology, because this was the major hurdle. Probably if you look into the development, like starting from 90, that the battery is the major bottleneck for this electric vehicle. So people have come up, lot of research have come throughout the world to improve the battery, and day by day battery is improving, and of course we expect it had to go very mass production, I mean, also. So a lot of variety of the battery you will find, like, I mean, also VRLA that are typically liquid battery, the life is very high, like maybe 25 years or so, like. So that's about little bit about battery, but if you are more keen, then you can certainly go through probably the website and get enough literature for that. Another is the drivetrain for typically for all these your hybrid electric vehicle have been both, like, I mean, so series and parallel have been there. So a lot of concept have been there for hybrid vehicle. That is typically now new old technology, and now but we are coming completely. So these are all hybrid different configuration. Like I can probably skip it. Now it's coming only the your total electric vehicle, which typically in case of many stations we are not using even the gears also or single stage gear. Like e-rickshaw, we use single stage gear only. You know, to have a like a clutch and all that. So a lot of concepts are coming up in all those in your drive chain also. So coming to the typically the kind of motors, like, I mean, so we expect the motor it should give a high stand power and high power density, because you want to fly, including like a two-wheeler. I will just come to how fast you want, and you have a high torque at low speed to starting and climbing. So these are the requirement in general, but with the electric vehicle probably can provide much better, like a typically high efficiency during regenerative braking. Regenerative braking is not there in your internal combustion engine vehicle, but here you need even a regeneration also you need a high efficiency. I mean also, so those mode of operation were not there, and very important is that what is the requirement? Okay, in electric or your hybrid vehicle. I mean these are the very important, like electromagnetic and all the additional requirement are there for all the vehicle. So we have a lot of motors, but the major motor Tesla have used the cage induction motor. I'll talk a little bit. Many manufacturers are using squirrel cage motor, but the major motor have been like a typically like a reluctance motor, which in India also Eddy Current Drive Limited and for Mahindra also manufacturing, and synchronous reluctance motor and PM assisted. Of course, PM different kind of PM motors are used, like in that case, whether surface, inside, interior. So permanent also are a variety of motors, like, I mean, as a main drive motor, but otherwise you have a probably more than 20, 30 motors for ancillaries or auxiliaries for the electric vehicle also. So you prefer to use the brushless motors and with their. So Tesla has come with the cage induction motor because it is a low cost, and moreover, I can tell you if you go to the rating around more than 10 kilowatt, the efficiency of induction motor is also quite high, quite good with the variable frequency drive as well as with the cage bar of copper, like, I mean. So this is typically the characteristic required for your vehicle propulsion system, that you require initially high starting torque, but after that you require a like a constant power characteristic that you see typically. I mean for the vehicle propulsion system, automobile engine give this kind of characteristic. Okay, you have a torque like this, your torque requirement is like this, but automobile, I mean, give this kind of torque and this kind of power. So to match this characteristic, virtually you have to use the gear. Okay, you have to use the gear assembly, which is a mechanical assembly, and you can understand your maintenance and tear and wear. But the electric motors, and that is the reason you have to form these characteristics. You have to use the gear, and you have to get a constant characteristic which was shown the requirement. Like, so you go to when you want really typically a high torque. Okay, you have to, and typically you have to reduce the speed, so you have to go first gear. I mean, you reduce at low speed, you have to increase the torque. Fourth gear, you require that much torque only, but in first gear, you get the torque even more than 4 times or so, 4.5 times or 5 times. That is required at the starting at low speed. So that is the reason you have to use so many stage gear, because the engine characteristic are not matching with the your vehicle propulsion system and gear requirement is there. But if you take an electric motor, it shoots without any gear, very well characteristic requirement with power control. And if you are using typically your brushless motor, you have a variable frequency drive, so you can very easily, efficiently match the characteristic of the your vehicle with the help of electric motors. Like so, you don't need the gear, you don't need the mechanical arrangement, and number of components are reduced drastically down. So that is another reason why we have to really go for electric vehicle, or it suits very well for electric vehicle also. So single gear might be there. I mean, in e-rickshaw we have a single gear only because you want to reduce the speed around 3,000 to 300 order of that. I mean, like, and the reason being at high speed, of course, this motor cost goes side weight cost goes low. I mean, typically even for permanent brushless DC motor which are used in e-rickshaw also. You can call it like what are the inference electric motors are ideal for traction devices for vehicle, and they have been already in operation like your trains as well as metros. Metro have a good example because they have a very high regeneration. Like train may not have that much regeneration because they run for longer distance very fast. I mean, you not apply the brake, but of course, you have to apply the frequent brake and regeneration substantially in metros. Like so, they are quite noise is also less, efficiency is high. So all those benefits which you think about from in a vehicle which comes from electric motor. So there is no problem. And for short period, you can have a overload also, which is required in vehicle. Like so the motor initially people use the DC motor, but DC motor have been a problem because of component brushes and solid state control really have a problem of failure of component. Apart from maintenance cost, size, weight all are high. The induction machine Tesla have picked up, but permanent machine, lot of manufacturers have come with the permanent brushless machine of both kind. Permanent brushless DC motor for small rating, like your e-rickshaw as well as two-wheeler. Lot of manufacturers have come in India, and for of course for high rating we prefer to PMSM. I mean, like permanent sine fed motor, like. And people are, of course, use the synchronous reluctance as well as reluctance. Synchronous reluctance machine is giving higher efficiency than induction machine because there is no losses in the rotor. And of course, you can understand all these are used with the variable frequency to control the speed and to match the characteristic of your complete drive with your electric vehicle, like because there all the time you have a dynamics in electric vehicle, like also, including regeneration we talk about. So initially people use the DC motor, but later on nowadays nobody using the DC motors. Like so, a large manufacturer are using the induction motor, and if you design with the copper bar, I mean they provide good high efficiency in slightly high rating around 15 to 20 kilowatt. Tesla have used initially even around 80 to 20 kilowatt motors, and which are reasonably high good efficiency around 95% or so. So, but the motor was very robust, like in the sense you don't have like a fear of permanent that the permanent will demagnetize or their property will lose with the temperature and all that. Those fears are not there in your squirrel cage induction motor, which are used extensively. I mean, like so, induction motor are the benefits are there. Like typically, you can think about with the copper bars and all these efficiency. I mean, like, but of course, there are some disadvantages also that require the magnetizing current or reactive power. All those issues are there compared to, of course, that's the reason people start using the interior permanent machines also. I mean, like, so, I mean, who is using induction machine? These are the typical example like GM have used, Audi have used, Nissan have used, Hyundai also using, and of course, the Tesla was the first to put into the market. I mean, your induction motor. They are using like an induction motor. Still, they are using, of course, in front wheel, back wheel. They are start using now maybe PMSM. So they are using kind of concept like. But you can understand what is a good efficiency like of this. I mean, you in 15.6 unit you go to 100 kilometer. Like I mean, if you look into from the solar, it's a only the 15 means around 30 rupee. 30 rupee you'll be able to go around 100 kilometer if it is generation is from solar. I mean, because electricity from the solar is 2 rupee 34 paisa, so you multiply 2 rupee 34 paisa from 15, so it will be not more than 30. I mean, around 40 rupee. So 40 rupee means you will be able to travel 100 kilometers. That's the fuel charge, like, and you can have a range of 475 kilometers around with the one charge of battery of 74 kilowatt hours, like. But you can think about what is the maximum torque and maximum power requirement because that is required for starting a dynamics also. Suddenly you want to stop, suddenly you want to accelerate. All those requirements are there, like and you want to accelerate up to typically in 4.6, 4.67 at a typically to a speed of 100 kilometer per hour. So you can think about less than 5 seconds you want 100 kilometer per hour speed, like as far as. So typically, I mean, this is the Tesla another model where they have used the induction motor. Okay, Mahindra. also use the induction motor. Ford also use the induction motor, a different model of the Ford also, and of course the Tesla, another model like also. So there are plenty of manufacturers who are using induction motor on like. So we cannot say that okay, these are only machine can be used for electric vehicle. The another one is typically like your pomegranate machine. Pomegranate machine we have of course two types. Geometry are of many types, but mainly classified into type. Pomegranate brushless DC motor, which are used for load rating like two-wheeler and three-wheeler, like e-rickshaw. Pomegranate brushless DC motor is there, PML DC motor there. But for larger rating, we use PMSM, like Seinfeld motor. Like initially, PML DC sensorless and control was easier, but now with the processor and the lot of algorithms, the PMSM control becomes much easier and cost effective because you know to use the sensor. So PM also used permanent brushless machines are also used by many manufacturers like Nissan in their model, and you can think about like how much is the typically motor rating like a 320 Newton meter, 110 kilo, and of course efficiency also is quite high, and it can go 144 kilometer per hour. So these are the acceleration, fast acceleration, top speed, energy efficiency. I mean these are the major requirement by the public. You can think about. So this is another one where PMSM is used. Okay, another model by another company called Volt. So you'll find a lot of manufacturers have come with the PMSM like also. I mean, typically, I mean, these and including two-wheelers like 82 kilowatt. Can you think about this motorcycle where the car is using typically 60 kilowatt motor, but your motorcycle is using 82 kilowatt because this is the, I mean, the vehicle for teenagers like, and this is the maximum sale expected in India. Like, I mean, major population which I have shown in initial slide like, and typically you can think about 82 kilowatt, I mean the maximum power rating of this like also, or here also 34 kilowatt with interior permanent motors. So a lot of vehicle two-wheelers are also using now permanent synchronous motor like also for different capacity, 34 kilowatt like, and of course the car is using like 81 kilowatt, another kind of model of car. So a lot of manufacturers are using typically like here it is, even Tesla start using in some their rear, I mean, wheel, they are using induction motor, front wheel, they are using PMSM. And they'll start using, I mean, initially they use induction motor only, but they realize that the benefit, okay, for rear they took induction motor, front they use the PMSM in many of their model like, okay, he also using PMSM. So a lot of are using PMSM and permanent brushless DC drive are used by, of course, your two-wheeler, I told you, the small rating, like a 2.8 kilowatt or 5.4 kilowatt. Can you think about this vehicle? You know, what is the rating this of PMLDC motor? Only 215 watt. I mean, like a two-wheeler was with the 84 kilowatt and this is with 215 watt. So can you think about 215 watt? Why this is there? Because it don't go for high speed. Who drive it? The girls and women. I mean, women is going to office. I mean, wearing the sari and they don't want to. I mean, their hair or even a sari should fly or their dress will be affected. So they drive not more than 15 to 20 kilometers per hour speed. But the fuel efficiency, can you think about? I mean, 20 ampere hour, 48 volt is 960 only, and you cannot discharge completely. Okay. I mean, even it's a rating of the charger is 150 VA, not more than that. So even a less than 1 unit, it goes to 50 to 60 kilometers. Can you think about electricity cost of 1 unit? I mean, if you talk about in Delhi, I mean, like with the, I mean, if you are not consuming 200 units, you have to pay 3 rupees 75 paisa. So in 4 rupee, you are able to drive as much as 50 to 60 kilometers, this two-wheeler. Like, I mean, so how much economic it is there? If you could have used the petrol, you could have certainly used the petrol of 200 rupee. In place of that, you are going to use only 5 to 6 rupee electricity or fuel here. Like, I mean, so the difference in you can call it the fuel charge is very substantial. I mean, you are coming from 200 rupee to 4 5 rupee only or so for running charges. There are plenty of this kind of model which use the BLDC. Also, two-wheelers are major segment for two-wheeler and three-wheelers of major segment like of different rating, varying from typically from I told you like a 200 watt, it goes to like a 2.5 kilowatts like loader and all that. So, and this is of course the vehicle in India like called e-rickshaw used for different commercial activities. You will find the Indians are using crazy about it. And the rating also start from 700 watt, go to like 1.25 kilowatt or so of different sizes, different direction. And what is coming from outside, it's only the motor and controller, which is 6,500 rupees. Earlier it was 12,000 rupees, now it is 6,500 rupees. Only as a motor controller. Remaining part out of your 80,000 cost, Remaining part all manufactured here. So even at less than 10% is really coming motor and controller, and your all the battery, tires, body, everything is manufactured here. Like I mean also, but they are using all BLDC and they are using certainly single stage gear because the motor speed is around 3000 to 3300 RPM, which have to reduce around like a 200 to 300 RPM. So 1 to 10 gear approximately is used in all the three-wheeler e-rickshaw, but they are used for different activities. Like I mean, you can think about, I mean, like a loader. I mean, people start using for different variety of these e-rickshaw for different activities, different type. Like you can think about for green cart, electric green cart, or you can think about like a school children kind of school rickshaw, or you can take your garbage carriers e-rickshaw, or you take like a ice cream vendors takes about like this e-rickshaw, or your vegetables and all those taken by e-rickshaw. But all they use the BLDC. Another is the reluctance motor, which is also manufactured in India for electric vehicle by Eddy Current Drive Limited, as well as the Mahindra start manufacturing this like also. So they all this is the only motor which gives you very high starting torque. So it suits very well for engine starting like. And well, its design is very simple. It's a very cost effective, no effect of temperature because there's no magnet, no winding on the rotor. It has plenty of benefit, like many of you could have gone through in the literature for that. So there, I mean, many manufacturers start using this also, including in India. Another motor is synchronous reluctance motor, which is coming big way. I mean, we were after this motor probably long time. I got developed in Roorkee in 1985-86 in B project as well as ME project, and we were after it, but its development was a problem. And now with the variable frequency drive, it has come in last 5 years by ABB Siemens, piloting lot of application because the rotor losses are completely absent and no cage bar. Because you are operating variable frequency drive, so there is no need of a cage bar or damper bars in the rotor also of the now present day synchronous reluctance machine. So it is also coming up lot of for with a lot of benefit of the torque speed characteristic come in all machines, how they are providing with the good efficiency as well as torque speed characteristic, which matches with the traction requirement which I mentioned already for constant power drive for higher speed and low speed is a constant torque drive also. So that is anyhow that which motor you should select. That's the only selection. And examples, of course, free electric cars are there using. You can think about how what is the level of the status of your electric vehicle Tesla model. I mean, you want to fly to 233 kilometer per hour in 7.9 seconds. Okay, with the good energy efficiency and large range. Also, so a lot of manufacturers have come. I mean, that's the reason I ask my student to put a lot of photograph that people get a confidence that a lot of manufacturers are there and they are coming to India also. Some are already Indian manufactured, but most of the multinationals that are coming to India, looking a good market in India. I mean, there are maybe more than probably 100 manufacturers might be with the several thousand models for this electric vehicle, including only for car. But if you talk about other vehicle also, it will be large number also. So that is about the your how like a your EV. Another is about charging technology because you cannot go to the vehicle without charging technology. So charging is a bottleneck. Even I do remember when we really put it in Delhi or Metro City like a CNG, there was initially a lot of problem, lot of queue for CNG. But now slowly it relieved. So in electric vehicle, government is very perceptive that we should build up the charging infrastructure initially. But fortunately, the situation in electric vehicle is much better than your CNG vehicles because you can charge in home also as well as you can go to the your charging station also. So here the advantage being that you can charge in different location also. It's not necessary every time you have to. So there have been a different kind of chargers and kind of your AC charging as well as DC charging. I mean, and there have been a lot of standard like Society of Automotive Engineers in America, Japan, European. So they have a different standard like a power rating. Okay, maximum current charging, typically the status, all those are there. So a lot of standard already come like for charging. I mean, typically like of large DC charging. Then standard about the connectors and charging concept also. You can think about a lot of standards are there. Okay, for different charging of DC level 1, level 2, level 3. Similarly, AC also level 1, level 2, level 3, and then the connectors. These are also standardized, like also, and there's I mean, male, female connectors because they have to draw very large current. Like, I mean, so certainly this connectors design it becomes very, very important, like for different standards, and they should be compatible from one to another. That's also important. That's the reason why you have to. I mean, it should have a very large current and large power pickup, like with different kind of connectors you can think about are available. And then communication protocol with the all the chargers like. where you have to communicate with the battery. I mean, the charger have to communicate with the battery, like whether it is outboard or so. So you will find a lot of vehicle with the AC charging. These are the vehicle with the AC charging. I mean, like so, and you have a vehicle with the DC fast charging also. We talk about that. Okay, we'll be able to charge very fast charging with the proper communication protocol, as well as the Tesla model with the different fast charging. So you have a lot of charging. I mean, we have a lot of option in the charging, like whether you have a wireless charging or you have a conductive charging also, and single unit also, or you have a vehicle part also you want to use as a part of charging for. Uh, so there have been a concept of onboard and offboard. Onboard means your charger is on the your vehicle. Outboard this means your charger is lying either home or maybe commercial place, or it may be your pet, typically the charging station. So different concepts have been in the charger. You can call it like it's a onboard charger. You connect to the grid like in a home, and you can charge your vehicle battery also. So you have a like here you have a small onboard charger, and then you have a fast DC fast charger also to charge same battery typically. So that concept also come that you cannot say from this petrol pump only we will take a petrol. I cannot take from another petrol pump. But here is the option. You can charge in the home also with the wall socket with the small rating on charger maybe for whole night, or you can charge with the fast charger also. These are the facility you have to provide on vehicle charging. I mean, then only people will be able to adopt the technology like and a lot of concept like a small rating single phase, three large rating three phase on board. But on board the concept is a lot of manufacturers come in the charger with different power capacity. I mean, you can think about like a power capacity around 3.7 kilowatt, which is very popular for single phase order of that, and then high rating is 7.2 and 2.22 kilowatt. So majority of this onboard charger they are order of typically 3.7, 7.2. These are the typical rating with the single phase that in your home supply is a single phase, so you should be able to charge without much problem. But when you go for three phase, higher like 11.5 up to that charging rating. But a lot of company are manufacturing. Well, think about all the company are manufacturing throughout the world, like also including the with the relation with the motor rating too, typically like so a lot of onboard chargers are manufacturer are there like, and then you have a offboard charger like a petrol pump. Okay, how it look like that you have a charger here and you connect your battery vehicle battery to the offboard charging station like and there are of course different requirements because charger is not in the heavy charger is not in the, so you can have a fast charger also in that case like. So this is kind of fast charger you need 15 to 20 minutes on highway, or commercial 30 to either AC or DC 30 to 120 minutes. In same charging station you will find AC node, AC charging and DC charging nodes also. Like a mall or commercial places or offices, you can charge either in 30 half an hour to 2 hour or maybe 8 hours. Like you are keeping a whole day you are in office, so it can charge very well with no problem, or in the homes like also. The typical charger which are available well in India, one we have in our campus also, and a lot of manufacturer come with this kind of standard like 50 kilowatt up to 125 ampere and voltage range 50 to 500, because for off-board charger is very important. Whether you charge e-rickshaw or you charge Tesla car, you can go and charge from there, and you have a communication protocol and efficiency. So a lot of manufacturer with this rating have come. You can find this as a Tesla, then Lofan, then Triton, then you have a ABB, Control, then FEs, FEC, and then Snyder. You just see the name Nissan. So they have a charger of the similar standard rating for offboard charging. I mean, like a Tesla. Of course, Tesla have a larger rating as well as 50 kilowatt also this one, and 250 kilowatt fast charger also super. They call it like a supercharger like. So they have a different kind of or Orca, or you have like another manufacturer like so a lot of manufacturer chargers are available typically. V2G chargers like and then extreme fast charging, which shown like you can charge in 7 minutes also, but the rating of charger is 350 kilowatt hours. Like your battery should be capable of so 200 kilometers you can go to with the charge of 7 minutes or you can charge in typically couple of hours. So that's the typical rating how charger board charger looks like, and then the typically some standard for charging also like you can think about. Are available for variety of. So this is the charging station, which are of course now you can call it not only charging station, charging infrastructure. You have energy storage like battery. You have a PV also, and you have a AC bus for charging like, and you are taking power from the grid from PV from energy storage also. Yeah, like. Then you have a DC bus charging also. So you are taking power from the grid from PV from energy storage and vehicle charging are there. So, and then of course with the different rating, fast charging also with the DC and fast high power rating 250 kilowatt also. So a lot of variety of charger have appeared like a DC charging, AC charging, fast charging, express charging. Tesla supercharger, which have been 125 to 200 kilowatt with the input AC voltage, DC voltage of different rating with the different efficiency and how much you want to time you want to charge that. So different manufacturer like around, have a lot of models like of the chargers or typically another lot of manufacturer come by DG part. So that is about normal charging, conductive charging, like onboard charger, offboard charger, or mix of the two that both you have. Another is the wireless charging. So why you have a wireless or we call it inductive charging? The concept of wireless is that one is the major heavy connectors, difficult to handle wire, electric shock hazard, tipping hazard. You can think about how the connectors and another major problem in the you are in a good place, but think about a country where you have a vehicle in the snow. Your garage is full with the snow, so neither you difficult to put the connector and difficult to take out the connector under such situation. Like, okay, so that's another reason you need. And of course, there are concepts like a static charging, wireless charging, and dynamic wireless charging. So lane itself is there. You can reduce the capacity of the battery in dynamic charging, but static charging, of course, you put on the here and it will charge like. So a lot of manufacturers, the basic concept in this, you have a power factor correction converter, you have a DC-DC converter, then you have magnetic coupler, then you have further AC to DC, and then DC-DC to charge the vehicle. But you have a small charger for onboard charger also, which I mentioned it, okay? Also, and these are the standard used for that purpose. These capacitors are to provide two purpose, that DC will not go to transformer, primary and secondary, and this is the place where you can have a couple of feet distance between the this side of core to this side of core, like. And apart from that, you have a typically this coupling capacitor, so they serve the purpose of reactive power. Apart from that, they serve the additional purpose of your blocking the DC going into primary or secondary also. So a lot of manufacturers have come like typically in this wireless charging. These are the typical distance you can think about, like 18 centimeter air gap with a different power rating up to 1 kilowatt, 180 kilowatt, and different efficiency also are available. In the world by different manufacturer like wireless charger also. So there are a lot of industry have started manufacturing the charger even like a typically to 20 centimeter. And many have a standard frequency like around 80 to 85 kilowatt. That's considered very well. Another is renewable energy integration into the charging structure that you can take even on your typically where vehicle are parked, you have a solar integration on the your kind of roof on charging station. Not only solar, but you have wind integration also, which is coming big up. So you have a large battery here which charge from renewable, and then you can have a fast charging, and you can take energy from different sources. Grid, solar, wind, all are there. So lot of integration are coming only directly to charging also. Solar and wind integration also. Another concept I had come with the renewable for a concept of a smart grid also, also. So that concept is coming day by day for solar power with the integration of renewable power in that. And this electric vehicle certainly have a role in smart grid because you have a concept of the management related to that as a smart meter. So you have a concept of vehicle to grid, grid to vehicle, all concepts are there with the smart grid and with the green energy flowing into that. And it's a grid to vehicle concept is also there. Vehicle to grid also concept is there. You can think about vehicle to grid is also there. You can sell off like when cost of electricity is high. Also, home to vehicle is there and vehicle to home is also there. So a lot of concept. Okay, vehicle to for the grid is there also. So you can think about like what is X here. Vehicle to X. It may be vehicle to grid, vehicle to load, vehicle to home, and vehicle to vehicle with the smart charging. So all these concepts start coming which support the grid also. And with proper communication protocol and all those concepts are there, vehicle to grid, vehicle to load, vehicle to home, vehicle to vehicle also. As far as I have a closer look to about Indian, we have committed that by 2030 we'll have certainly government have declared 100% electric vehicle, but of course it takes time, but of course we expect that it will come as a big way, as I've told you, like in India, scene is like 84, typically 84% are like a two-wheeler, three-wheelers, okay? And this is the so much economy. And you can think about worth of crude oil that will be avoided, like if you go to the electric vehicle, and these are the different, concept of your initially MNRE and now FAME has put the concept like how the map is there for 2015 to 19 go on to for, like a different charging infrastructure for the purpose of this. So it is what Indian policy is there that you must have so many vehicles by 2000, typically 20, then 21 and 22 or so. And big capacity, how much is the installed capacity for this battery charging and other infrastructure. So a lot of industry are coming up, for charging infrastructure also in India too, and they have start some putting in like in Nagpur, the charging station, then in Delhi, in NTPC, even in our campus also one Tesla charger with the car is there for, of course, research purpose, but people are start using it effectively. And then you can think about like a different Hero Electric also start making the different charger for different batteries also. So plenty of, I mean, you can think about how many chargers and other concepts they start coming of different electric vehicle in India too. I asked a student to put on that. And really, what is the typically Indian road vehicle at the moment with the 3 crore? We cannot deny it. Typically, like a e-rickshaw by different manufacturer. I mean, hundreds of manufacturers are there, like typically of e-rickshaw around even Delhi also. And I mean, large number of vehicles are there that, as you see, it like a, it's a start from 850 watt to 1 kilowatt or 1.25 kilowatt with a battery of 100 ampere hour with 48 volt, charges 8 to 9 hours, and normal charge is 120 hours. So there is no regeneration, but people are start now looking for improvement of technology, putting regeneration as well as putting the solar on the rooftop like on that. So this is typically the specification charger kind of, and then people start putting solar also on the rooftop. You can think about solar, which really increases the range by typically 30 to 40% range of this by putting solar panel on the roof, like also, and different concept for different applications, which I already mentioned about. Typically, how battery, how the solar integration, without solar integration, I mean, like if 80 kilometer to 40 kilometer increases because of solar integration into it on, and then how much solar, how much electric, and different manufacturers for these, like, I mean, has come forward for all these concepts. Like there have been a lot of standard throughout the world, like IC and other standard also for electric vehicle as well as chargers. I mean, these are some of the standard I just will mention. People feel. So with this, I would like to conclude. These are the some of the references. If you have any specific question, I will be happy to answer. Okay. Professor Bhattacharya, back to you. Okay. If any question is there, I will be happy to answer. Okay.
Yeah, I am seeing few participant questions.
Okay.
So I think you can now interact with sir and put forward your questions.
Oh, sure, sure. No problem.
You have already written the questions in the chat window, so I think you should unmute yourself and interact. Professor Bhim Singh.
So somebody have to be, I think somebody have to monitor the question. I cannot see, so you can see
Yes.
the question.
Sir,
So you can pass on the
sir,
question.
sir, may I ask the question?
Sure, sure. Go ahead. No problem.
Sir, is there any effect on the life of the battery? Suppose if we use fast charging on the highway, suppose if we use the fast charging to charge our battery within 15-20 minutes, so will it affect the life of the battery?
No, no. I don't think any, because now the technology is so improving. I met last week, the person came in the March to me from who's working in Tesla and he want to have a startup here in India. His own small startup he want. And you know,
Okay.
he came with the concept that even your lead acid battery, he feel that it can be charged. They tested it, that can be charged with the sea.
All right.
I mean,
All
lead
right.
acid battery, we are charging at the moment 8 to 10 hours in e-rickshaw. But he came with the concept that we should be able to charge in 1 hour.
All right. All
Even
right.
a same lead acid battery we consider as a concept of mythological concept that okay, it's a very slow battery, life will go down and all that. And they have tested that it's not affecting the even a lead acid battery can be charged in 1 hour with the fast charging.
Okay,
And he
sir.
want to
Sir,
launch this thing in
which battery type will be perfect for the e-vehicles? I mean, it's good for
that
e-vehicles.
no, at the moment it is coming lithium ion. All the cars which I
Okay.
have shown the photograph, all are with the lithium ion. But lithium ion also have a, and you know, the battery number of charge are like the vehicle easily can go with the 15 years with battery life, okay, without replacement.
Okay.
And you can
Okay.
understand at the moment petrol car with the 15 years, na. Diesel car is
Yes.
only
Yes.
10 years, like, okay. So you know to replace the battery even for whole life of the car,
All
okay.
right, sir. Thank
So
you. Thank you very much.
that is the technology has come of this nature, okay.
Okay, sir. Thank you. Thank
And everybody looking towards India because your requirement is so huge.
you.
130 crore vehicle you are expecting in up to in next 10 years. Okay. I mean,
Okay.
India, every Indian citizen, you can say, have a vehicle. In Delhi, we have a lot of maybe 30 to 40% people live in Jhuggi cluster, but they also have a 4 vehicle. You know,
Okay.
they sit in metro, they sit in the buses, they have a two-wheeler, and they sit in taxi also. Okay. So you can think about, I mean, like if people around more than 1.25 crore people living in Delhi, you might have a vehicle propulsion system around for the 5 crore people in Delhi. You have a
That's
car, you travel in metro also, okay? And you travel even in your taxi also. You travel even in your sometime two-wheeler also. Okay, and parking has become a
yes, sir.
very big hustle in like a Delhi, especially for the societies and your you can call it residential complexes, like because space is not that people never plan. Now new of course the flats and the I think society are coming up with the proper where you can call it the parking, but earlier parking was not made so many number of the houses were made, but even then one house have a four vehicle. That is a major problem.
Mm. Thank you very much.
Okay, you are welcome. Any other question?
Sir, good afternoon, sir.
Good afternoon.
Sir, I am from Tamil Nadu, Rameshwaram, sir. So I
Mhm.
have, sir, in future, electric vehicles will used in off-road vehicles. It's possible, sir.
Eugene?
Off-road vehicle, it's like a desert area, hill stations.
There is no problem. There is no issue related to that. Okay,
Okay, sir. But charging issues will be there, sir.
you can do by solar. What is wrong? Put on rooftop. Okay, people
Thank you.
have come worldwide with a different concept.
Yes, sir. Thank you. Thank you, sir. Thank you.
Okay. Any other question like?
Is there any other
You can take
question?
up the questions later on and put it to Sir.
Okay, sure. I mean, mail or something.
Yeah,
Professor
yeah.
Bhattacharya, I think we can probably now converge.
Yeah, if there is no questions, then is there any questions for anyone? I can see some few chat questions. I think those have already been answered. Someone has asked what is the present research area in electric vehicles.
Oh, present research area. I see the research area is plenty. I mean, like, I can tell you 5 years back, I asked my one of the research student, look, bring the two charger for your three-wheeler like a e-rickshaw and open one and see what is inside. And when we open it, of course, he is not able to recognize all the component. I asked my another student from industry who also finished PhD now, and she also finished PhD. And what he says, sir, this is this circuit. I found it when they just showed me the circuit. I told you have hundreds of improvement in that. Within 3 years, he have a dozen of transaction paper. Okay, final product, I can tell you. Like there was, we started for power factor correction. That was our motive to improve the power quality. That grid with the grid should be comfortable, but we are able to improve at least 4 to 5% efficiency also of that charger. Apart from that, we are able to reduce the ripple in the battery also drastically down 30 to 40% to 4 5% only the ripple we are able to reduce also. Like so, whatever the publications, he send it in top journal also, and we have a couple of patents as well as probably a dozen paper by that girl. Now I put around like a 10 student on the charging only, as well as around 10 student on different motors, but not for car. Let us say I told go to e-rickshaw only. Okay, all brushless motor for e-rickshaw. And I can tell you what is the status. I thought it in e-rickshaw people are using permanent brushless DC motor. So I asked one of my students, why don't look into this motor? Is somebody there? And I found in market, Chinese are already offering the switch reluctance motor also for e-rickshaw. Only cost-wise a little higher. I mean, this motor that time BLDC was around 12,000 rupees. This was 16,000 rupees. So I told him to pick your couple of, and he's working on that. Of course, I told you that there is a substantial scope even for those three-wheeler like a commercial vehicle. There is no regeneration, okay? And you have to leave, even if you change the battery and you take a fast charger, the person can earn the 3 times the revenue. At the moment, what e-rickshaw person have, he pays 250 rupees as a rent, 50 rupees as a charge, 300 rupees he give the morning to the guy, and whatever he earn in the day, like 800 to 900 rupees, and this guy earn 500 to 600 rupees every day. Okay, the labor who was earning hardly 200 rupees, now he able to earn 500 to 600 rupees. But suppose you are able to provide the technology with the right battery and right charger that he charged by the time he taking meal, he is able to charge again. So then he can certainly run the three shift and earn the revenue of not only 500 to 600 rupees, but able to earn 1500 to 2000 rupees every day. So this is what you have to improve the technology. Are you able to follow? Your neighbor has given a technology, a concept. You have 3 crore e-rickshaw, but the concept of earning the 3 times by the same person, you have to do the research for that. Are you able to follow? So I found plenty of scope. We are the outgoing generation. Like I'm probably, maybe I'm 65, maybe few months, of course, I will continue maybe 4 or 5 years because there are 60 PhD students are working. But for you as a big career, but you can think about there's a very substantial scope in every product. Okay, but you have to think about developing new product also. I will follow new concept for India. You might have seen many e-rickshaw are modified for different purpose. Okay, and it has become a vehicle for India in the sense that villagers, especially the girls students, are coming from village. They have a lot of problems coming to city 8-10 kilometers. Now this is the vehicle very calm. They not to spend much like a 10 rupee for one side ride. I mean, it has given a smile faces for the people like anything for shorter distance and major population which live in semi-urban areas or even the rural areas also. So you have a lot of potential. Charging infrastructure is required for them. So I mean, there is no depth of the research required for this. And you require different kind of vehicle, different kind of charging station, different kind of renewable integration, small rating to high rating. So as far as research, I found it like a probably very big scope. Like, okay, I hope it is up to some extent. I cannot probably talk about too much for long. So, but if you want some more, then you can write to email to me, and I can probably reply specific. Okay. Yes, sir.
Thank you
Hello,
very
any
much,
further
sir.
questions?
Sir Gupta, thank you very much. I mean, nice to go. Okay, namaskar. I mean, it's my pleasure.
Thank you for attending the session. I will share the
Okay.
PPT with all the participants
Okay,
later
sure.
on.
Like, go ahead. Like, okay.
And you can always have an interaction with sir over email if you want to, and sir can be
Sure. Like,
in his,
yeah.
in his email ID. So anyone having any questions or doubts beyond these sessions, you are free to interact with sir. So thank you, Professor Bhim Singh, for finding your time by interacting with this session.
Sure. Okay, sure. So I
Hope
can
to
go
get
out now.
Hello.
I can leave now if you don't mind. Like, okay.
Okay, sir. Thank you. So thanks a lot, sir.
Okay. Yeah.
So dear participants, since we have got a bit late start, so what we have planned is that we will start the next session at 12:45, and after that we will break for lunch. We'll start up the next session by Dr. Vishakha Majumdar. That will be more on the stress management part. So whatever stress we have underwent from since morning, that can be relieved. So you can take a small break of 15 minutes, and then Dr. Vishakha will start from 12:45, and after that we'll break away from lunch, and then we will start the last session. So that is what the schedule right now. So anyone having any questions, you can ask me, or again we will catch up in the same way. The meeting link will remain at 12:45.
Sir, respected coordinator. Coordinator, sir.
Hello.